A distillation tower's bottom temperature may change during the course of operation, or it may be changed to alter product composition. The system's control loops react to changes in bottom temperature to maintain the material balance and the energy balance. We can use this simplified illustration of a distillation system to see how bottom temperature can be controlled. In this system, the bottom temperature is controlled by adjusting steam flow to a stab-in reboiler. This is accomplished by the bottom temperature control loop. If the bottom temperature set point is increased, the bottom temperature control loop responds by increasing steam flow. As a result, more of the liquid in the bottom of the tower is converted to vapor by the reboiler. The increase in vapor flow affects the tower's material balance. An increase in vapor flow means that a larger amount of vapor is condensed into liquid in the overhead condenser and sent to the overhead receiver. The level control loop for the receiver senses the increased level and increases the flow of the overhead product. Another result of increasing the bottom temperature is a decrease in the liquid level in the bottom of the tower. The level is lower because more of the liquid in the bottom of the tower is being vaporized. Since the bottom level has decreased, the bottom level control loop decreases the flow of the bottom's product. The control system's energy balance control loops react to an increase in the bottom temperature to maintain the system's energy balance. An increase in the bottom temperature means that there is a greater amount of vapor flow. As the additional vapor is condensed in the condenser and flows into the receiver, the temperature of the liquid in the receiver increases. The condenser temperature control loop senses the increase in temperature in the receiver. This control loop then adjusts the louvers in the path of the forced air from the fans in the condenser to cool the increased amount of vapors. In addition, the external reflux control loop senses the temperature increase in the tower and reacts by increasing the flow of external reflux to the tower. The increased reflux flow causes more condensation to take place in the tower. As a result, the temperature in the tower decreases. So far, we've looked at the effects of increasing the bottom temperature set point. The control system for the distillation process in our example responds to a decrease in the bottom temperature set point by decreasing the flow of steam to the reboiler. The control loops then respond to the change that has occurred in the tower's energy balance. Distillation process control systems can consist of many different combinations of control loops. The control system for a particular process is designed to meet the requirements for that process. But regardless of the process, a change in a process variable can disrupt the system's material and energy balances. Control loops are designed to restore the balances, but operators need to be aware of changes in their systems so that they can help ensure that products meet specification. Changes in the external reflux that flows to a distillation tower can affect the composition of the tower's products. When external reflux enters the tower, its lightest portion vaporizes and flows out of the tower with the other overhead vapors. The rest of the external reflux flows down the tower. The reflux helps to condense the heavier components of the vapors in the tower. A decrease in the amount of reflux entering the tower means that more of the heavier components remain as vapors and reach the condenser, where they are condensed and sent to the overhead receiver. The increase in vapors in the tower also raises the temperature in the tower. Now, an increase in the amount of reflux entering the tower causes more condensation to take place in the tower. As a result, more of the feed's heavier components are condensed and will flow back down the tower. And since more vapor is condensed, the temperature in the tower decreases. The tower's control system will react to either an increase or decrease in the tower's temperature. When there's an increase in temperature, the external reflux control loop senses the change and then increases the flow of external reflux to the tower. The increased flow of reflux condenses more of the vapors in the tower, and the temperature in the tower decreases. When the external reflux control loop senses a decrease in the temperature, it decreases the flow of reflux to the tower. In some distillation systems, the external reflux flow is kept constant. The amount of condensation is varied by changing the temperature of the reflux. Introducing cooler reflux into the tower has the same effect on product composition as increasing the flow of reflux to the tower. In this topic, we looked at how a tower's control system responds to changes in bottom temperature. We also looked at how product composition can be affected by changes in external reflux.